Welcome back. Today we're starting section 2 on normal distributions. So we started a conversation of density curves in the last section, okay? Again, density curves meaning everything has to be above the horizontal axis and the area under the curve has to be equal to 1. So normal distributions follow that pattern, okay? It is one specific class of density curve. Um, some things to know about normal distributions. The curves are symmetric, single-peaked, and bell-shaped. And they can be described by giving the mean and the standard deviation. All right. So sometimes you'll note it like this, okay? That's how you can notate a normal distribution, an n with the mean and the standard deviation. So if you ever want to sketch a normal curve, okay, just draw a bell-shaped curve. You want to label what the center is, the 3 standard deviations on either side of it, okay? So for example, the Iowa Test of Basic Skills vocabulary scores for 7th graders in Indiana are close to normal with mu or mean of 6.84 and standard deviation of 1.55. Or again, you can notate that as this is normal with a mean of 6.84, standard deviation of 1.55. And again, so what you want to do is you want to start just by drawing a bell-shaped curve, okay, if you're being asked to describe this. And then in the center, you're going to put that 6.84, okay? You always start with the mean. And then what you want to do is you want to say, well, one standard deviation above that would be 6.84 plus 1.55. 2 standard deviations above would be another 1.55 up, so 9.94. 3 standard deviations above would be another 1.55, giving you 11.49. Then 1 standard deviation below, 2 standard deviations below, and 3 standard deviations below. So again, that's how I would sketch any density curve that I need. Start with the middle and then just work your way. 3 standard deviations on either side would be appropriate to show. All right. Now, what can we do with these? Well, the first important thing is the empirical rule, okay? So basically for any normal data, now this only applies to normal data, what you're looking for is approximately 68% of the observations will be within 1 standard deviation, okay? And you can see that in this first image right here. Within 1 standard deviation on either side, about 68% of the data will be there. Within 2 standard deviations will be about 95% of your data, and 3 standard deviations will be about 99.7. About all of your data will be within 3 standard deviations. Okay. Now, how does this help us? Well, we can use this in doing some calculations. So using the data from the previous slide, find about what percent of scores are, and now I can specify things for you. So for example, I can ask you what percent of data is between what percent of kids got between 5.29 and 6.84. All right, so how many kids fall right here? Now, the first thing I know that this is 1 standard deviation away from the median, okay? Or that's the -1 mark. So -1 standard deviations. Well, if from here to here, 68% fall within there, well, if you notice, this is only half of that. So what that's telling me is only 34% fall between 5.29 and 6.84. Okay, so there's going to be a lot of kind of manipulation of areas to answer these types of questions. Okay? Now what about this one? 3.74 and 8.39. So we want to know how many fall in there. Now for this, I would kind of picture this in two separate pieces. All right? I'm going to look at this piece right here. So this is minus 2 standard deviations, right? So it's that 95% rule, but I'm only looking at half of that 95. So I'm going to take that 95 and I'm going to divide it by 2 to give me 47.5. On this side, we're talking about one standard deviation, but again, we're only talking about half of that. So this is going to be that 34% again. And then if we're talking about in both areas, so we're totaling those up, I would add those two values together. So altogether, about 81.5% of kids scored between 3.74 and 8.39. All right, how about this? Less than 3.4. So now we're looking at just that tail. Okay, and again, I'm looking at -2 standard deviations. So we're focusing on that 95% rule, right? 95% of the data will lie within that range. So what's that telling me? Well, that's telling me 5% exists outside of that range, right? But I'm not talking about the complete outside. I'm talking about half of that outside bit, or 2.5% of the data would be less than that bound. Or finally, here we have 8.39, which is right here, and 9.94. So we're looking between between 1 standard deviation and 2 standard deviation. All right. So this time I think the easiest approach is going to be subtraction, okay? Because I want you to look, if I'm going all the way out to 2 in this direction, remember, we're talking about half of the 2 standard deviation rule, so 70 or 47.5. If we're going out to 1, that's going to be 34. So if I want that in between, I'm going to want to subtract those. Okay, and that's going to give me 13.5% of the data. So for this, you really have to be good at manipulating areas visually. Okay, working around those different areas to see how to capture them. Now, those strategies only work nicely if you're looking at exact increments that are 1 standard deviation away or 2 standard deviations away. It doesn't give you any in-betweens, okay? So the next bit we're going to talk about is a more general way of calculating these percents, all right? So the standard normal distribution is a normal distribution with mean 0 and standard deviation 1. If variable x has a normal distribution, normal distribution with mu and standard deviation, with mean mu, standard deviation sigma, then the standardized variable, this, has a standardized normal distribution 0, 1. So what it does is it standardizes any normal curve, okay? Standardizes it to have a center at 0, standard deviation 1, to make these areas easier to calculate, okay? So let's take a look at how this works. Okay, what proportion of observations from the standard normal distribution are less than 0.81, between negative 1.25 and 0.42, greater than negative 2.3. So for these are off of a standardized normal distribution, okay? So again, center at 0, 2, 3, 2, 3, and then standard deviations counting in increments of ones. All right, so this is a normal standard curve. We want to know what percent of the area is less than 0.81. Well, 0.81 is going to fall right here, and we want the area less than it. Now, this is not a nice standard deviation mark, okay? It's 0.81. So we can't use the strategies that we just talked about. So here we need to go to the calculator, okay, to calculate these values. Now, I'm going to show you, it's a new area of the calculator. So let's go here. We're going to go into distribution. Okay, that's going to be another big one that we're going to be using throughout the year. Okay, so usually we either go into stat or we're going to be going into distribution when we're doing statistics. Now, I want this normal CDF command. Okay, this right here, because this is going to find the cumulative effect. Okay, so in this one, you're always going to want C. You're never going to be using the P1. And what this does, this calculates the area under the curve. Okay, so let's see how to use this. So here, for the lower bound, well, if you look, there is no lower bound. We're just going to negative infinity. Okay, we're just keeping going down, down, down. We just want less than. Well, the calculator can't understand infinity, so we want that lower bound. We're just going to put that lower bound as a very negative number. Okay, up to, what's our upper bound? Well, we're going up to that 8.1. Okay, right now that is our z-score. Okay. Oh, sorry, not 8.1, 0.81. I apologize. That would give us a ridiculous value. So we're going up to 0.81. And again, we're talking about a distribution with center at 0, standard deviation of 1. For you guys have an older model, this is what you'll be typing in. You get an area of 0.7910, okay? When we're reporting these areas, usually we go to 4 decimal points, okay? So 71 or 79.1% of the data lies within that region, okay? We'll have a standard deviation or a z-score less than 0.791. What about between? Well, let's sketch our curve. So we're going to be at 0, 1, 2, 3, 1, 2, 3. So to calculate this, so negative 1.25 and 0.42, we want to find the area of the normal curve with that. How many or what percent of the distribution has z-scores between negative 1.25 and 0.42? That's going to be the same calculation. So go to distribution, normal CDF. This time, my lower bound is negative 1.25 up to 0.42. And we're talking about the standard normal curve. So here, about 55.71% of our data is going to have z-scores between those values. All right, so 0.5571. And then our last one, again, standard normal curve. So here, from negative 2.3 up. So what would that calculation look like? Well, if we go into distribution, normal CDF, this time our lowest value, we're starting at negative 2.3 and we're going up to infinity. We just want greater than that. But the calculator doesn't understand infinity, so we're just going to put a very big number to compensate that will be close enough when it does that calculation. So hit enter. This time about 98.93% of our data is going to be have z-score greater than negative 2.3. So here, 0.9893. So that's how you can do it when you're not dealing with nice increments, okay? Straight to the calculator, and you can use this normal CDF command to find the areas between those values, okay? However, it does go a little bit deeper. Let's say I'm given the percent of data, okay? And I want to know what z-score creates that amount of area, okay? So for example, let's look at this. So standard normal curve, 1, 2, 3, 1, 2, 3. What z-score marks the 20th percentile? So having 20% of data less than it. Okay, so that's going to be somewhere down here. We don't know the z-score, but this time we know that area is 0.2. Okay, so this is a little bit of a different computation now. So when we do this, when we have the percent and we want to go back to the z-score, we're going to use inverse norm. Okay, so inverse norm is in that same distribution command and right here. So inverse norm, so I'm going to put in 0.2, 20% of the area is what's less than the z-score that I'm looking for. And the z-score is going to be negative 0.84. Okay, so what that's telling me is a z-score of negative 0.84 is going to give me an area 20% less than it. So a data point that has a z-score of negative 0.84 is going to be sitting at the 20th percentile. Now, why does it make sense that it's negative? Well, if it's at the 20th percentile, it means it's less than the median, right? It's going to be less than the mean because it's less than average. What about the 55th percentile? Again, let's draw a quick sketch. 2, 3, 1, 2, 3. The 55th percentile is going to be just above the mean. A percentile means everything underneath it. So this has an area of 0.55. We want to know what z-score makes that marker. Okay, and whenever you're looking for the z-score, that is going to be inverse norm. So the area this time is 55. What z-score creates that? 0.12, about 0.13, I should say. Z of 0.13. And again, it makes sense it's positive because the 55th percentile is going to be above the mean. Last thing, what z-score has 41% of observations greater than it? All right, so here having 41% greater than it, that's going to be, oh, about right here. Okay, so 41% greater than it. Now, the calculator, though. The calculator only computes areas that are less than. Okay, so that 41% isn't what we want. We want the area that's over here. If 41% of it is greater than, well, 59% of it is going to be less than it. So it's that 59% that we really want, because every area calculation is left-sided, okay, to the calculator. So make sure that when you go plug this in, if 41% is greater than it, 59%, 59% is less than the z-score that we're looking for. So what's our z-score? About 0.23. And it makes sense it's positive because it's going to be above the mean. Okay, so throughout the course, we're going to get really, really good at these computations. All right, so again, thank you for joining me for this. I know this is kind of a lot to take in a single lesson, so make sure you ask me if you have any questions.